question says, a chemist must prepare 900 milliliters of sodium hydroxide solution with a pH of 13.4 at 25 degrees Celsius. And he's going to do this in 3 steps. Fill 900 milliliter volumetric flask about halfway with distilled water. Weigh out a small amount of sodium hydroxide and add it to the flask, and fill the flask to the mark with distilled water. And your goal is to figure out what mass of sodium hydroxide he should weigh out and have a total volume of 900 milliliters such that the pH is 13.4. So sodium hydroxide is a 1A metal hydroxide, which is a strong base. So when you put it in water, it dissociates into Na plus aqueous and OH minus aqueous. So we have this basically chemical reaction. Well, what can we use to find some pieces of information, namely the concentration of OH minus? Well, we can use the pH to find the concentration of OH minus. If you recall, pH plus POH equals 14. Said another way, POH equals 14 minus the pH, which in this case equals 14 minus the 13.40, which equals 0.60. So this is the pOH of the solution. Well, we can use the pOH in order to find the concentration of OH minus, because the concentration of OH minus equals 10 to the negative pOH. And these things are discussed in several other videos on this playlist. If you're not familiar with them, it would be a good idea to review those videos. So in this case, the concentration of OH minus equals 10 to the negative 0.60, because that's the pOH, which equals 0.25119 molar, where there are 2 sig figs. So the pH has 2 sig figs, so we're going to have 2 significant figures. So now we have the concentration of OH minus, and we also have a volume of the solution. So basically, we want to do now dimensional analysis. We want to go from liters of solution to moles of OH minus to moles of NaOH using this balanced chemical equation, then finally to grams of NaOH, so we could figure out ultimately the grams of NaOH we should add to make this solution. So I'm just going to move the paper up. So starting with this volume in liters, 0.9000 liters of solution times, well, the molarity here tells us the moles per liter. In 1 liter of this particular solution, we have 0.25, again, that's the sig fig, 119 moles of NaOH. So this number came from the molarity that we found before based on the pH, the pOH, and finding the concentration of OH minus. And this should be, moles of OH minus. We now need to technically convert this to moles of NaOH. They are 1 to 1, but we are going to do it anyway. So we put 1 mole of OH minus on the bottom and 1 mole of NaOH on top. Note that some strong bases are not 1 to 1, so it's important to do this step even for the ones that are, so we don't forget it when they're not. Times, now we want to convert from moles of NaOH to grams of NaOH, 1 mole of NaOH on the bottom, and on top 40.00 grams of NaOH. And when you do all that math, you get 9.0 grams of NaOH. So in order to make 900 milliliters of a solution with a pH of 13.4, you need to add 9.0 grams of NaOH. This question is quite a lot of work, but this is a logical way of completing that work.